The objective of this video is to learn about slope and how to calculate it when given two coordinates, a table or a graph. The formulas for slope, well, the first formula, the one you're going to use the most, is this one where you have little m, and little m stands for slope. Why? I don't know. Look it up on the internet. Confusing story there. But the formula is y2 minus y1 over x2 minus x1, where these little subscripts tell you which coordinate the values come from. Another formula is rise over run. The slope is equal to the rise over the run, but that doesn't help you when you've got coordinates. This all boils down from the fact that the slope is based on the change in y over the change in x, also written as delta y over delta x, the delta being the Greek letter that stands for change in y or change in x, depending on that stands for change in, and you work with that. All right, here we have the formula. Point 1, x1, y1. It's not going to be written x1, y1. You have to know that point 1, the first point you see, is considered to be the x1 and y1 values. Point 2 is going to have the x2 and y2 values. But as it turns out, the subscripts don't really matter as long as you remember to line up your coordinates, your x and y values, vertically. Meaning that y2 and x2, the ones that come from the second point, come together here, and the ones at the first point here. If you switch them around and you do the y2, x2 here, and the y1, x1 here, it's still going to give you the same answer. So you can, in a way, ignore those subscripts. Let's take a look at an example and see what happens here. Working with the formula. This would be the first point, so this would be x1, this would be y1. This would be the second point, so this would be x2, and this would be y2. So if I work directly with that formula, I'd be doing 3, the second y value, minus the first y value, 6, over the second x value, 2, minus the first x value, 5. 3 minus 6 is going to give me negative 3. 2 minus 5 is going to give me, again, negative 3. Negative over a negative gives you a positive. 3 over 3 gives you 1. So the slope turns out to be 1. Here, we're going to do the same thing. We're going to swap it around, though. We're going to put the 1s first and the 2 second. So instead of 3 minus 6, we're now going to have 6 minus 3. y1 minus y2. Then we're going to do x1 minus x2 on the bottom. 5 minus 2. When you do that, 6 minus 3 gives you 3. 5 minus 2 gives you 3. 3 over 3 is 1. You end up getting the same slope regardless. You don't want to flip-flop the x and y value. You got to keep them vertically aligned. If you have y1 over x2, it's not going to work. You've got to keep these coordinates vertically aligned. The same numbers from that same coordinate are vertically aligned. All right, so let's look at this problem. This time, when I go to plug it in, I'm going to start with this problem, because this number comes first. So I'm going to work with that one. I work with the y values, because the y values are on top. Negative 2, minus 8. The x values, since I started with this y, I've got to start with that x. Negative 4, minus a minus 6. Now for the top here, if we do the keep it, change it, keep it, change it, we're going to be adding 2 negatives. When you add the 2 negatives, you add the 2 together, and the answer is going to be negative, so you get negative 10. Here we do the keep it, change it, we end up with negative 4 plus 6, which is going to give us larger minus a smaller. 6 minus 4 is 2. Sign of the larger, we get a positive 2. Can that be simplified? Yes. Negative 10 divided by 2 is negative 5. That's our slope on this one. Now, slope is a ratio, so it is a fraction, which means it is possible and even likely that your answer is going to work out to be fractions instead of these nice whole numbers. Don't be surprised when that happens. All right, here we're going to work with this. This one I'll start with this point instead. So I'll work with 4 minus 4. First minus the second. Second minus the first. We do negative 8 minus a negative 3. 4 minus 4 is 0. Keep it, change it, you end up with negative 8 plus 3, which is going to give you negative 5. But 0 divided by anything is 0. So the slope is 0. Don't confuse 0 for the slope as being no slope. A 0 slope means that the graph of this line is going to be a horizontal line. It's going to be a perfectly horizontal line. All horizontal lines have a slope of 0. It's not the same as saying no slope. Slope of 0 is not the same as saying no slope. It is an actual value, and that slope is 0. Let's try this one. We're going to do the y minus the y, 10 minus 8, 5 minus 5 on the bottom, because it's x minus x. 10 minus 8 gives me 2. 5 minus 5 gives me 0. Can you divide anything by 0? No. The answer here is no real slope. And it's actually going to happen anytime you have a vertical line. When it goes perfectly straight up and down, you're going to have no real slope. It's not 0. 2 divided by 0 is not 0. The answer is no real slope. And when you've got no real slope, it's because you've got a vertical line, straight up and down. All right, here's a word problem. John has to build a handicap ramp for his home. The front door is 3 feet above ground. His ramp will end 10 feet away from the door. What is the slope of the ramp? I kind of like the idea of drawing a picture for this one. And you can do that. It doesn't hurt to draw pictures. So here we are, we're going to draw a little front door. And that front door is 3 feet above the ground. And the ramp goes out from there, it goes out 10 feet. So we have 3 feet, 10 feet, and we got a ramp going down like that. What is the slope of the ramp? Well, I don't like the way I've drawn this. Let's take a look at it the other way. I'm going to do it this way. 3 feet here, 10 feet there. Can I do that? Nah, that's not a problem. If I consider this point 0, 0, that would make this point 10, 0, which would make this point up here 10, 3. There are 2 points. Working with those 2 coordinates, I can now figure out what the slope is. The slope is going to be y minus y, 3 minus 0, over x minus x, 10 minus 0, which is 3 over 10. Can that be simplified? No, I leave it as a ratio. Don't convert it to a decimal. Slopes are ratios. They are fractions. Now, if this was a rate of change, we would definitely want to include the feet per whatever, but this is feet over feet. So that one just stays 3/10. You may recall in the first slide there we talked about rise over run. When you're given a graph like this, you can find the slope working with rise over run. Moving from left to right, to get from this point on the graph to that point on the graph, I have to go up and then over to get to that point. How far I go up to get to the same level as that point from the first point? Well, I count that up. 1, 2, 3, 4, 5, 6, 7, 8. I went up 8. From there to get over to there, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 over. Up 8, over 12. Rise of 8, run of 12. Rise of 8, run of 12. Rise over run. Those are both divisible by 4, so I can simplify. And you must simplify fractions for your slopes. Both divisible by 4, I get 2/3. There's the slope of my line, working with rise over run. Now, the line had gone down. Instead, moving from left to right, I would have had to go down and to the right to get it, and it would have been a negative for the rise, which would have made the slope negative. Table of values. You could be given a table of values, and for some reason people get confused when they see a table here. In reality, what they've done is they've actually given you 4 coordinates here, and you can work with any 2 of those coordinates. So I'm going to choose this coordinate and this coordinate. Why this one? Because it's got a 0. I love seeing a 0. Why this one? Because it's the next one up and it has no negatives. I don't like to work with negatives. So let's work with these 2 points. Y minus y. The formula is y minus y over x minus x. So that's going to be 7 minus 1, y minus y, over x minus x. 2 minus 0. Which is going to give me 6 over 2, which simplifies to 3. If I had done the same thing with these 2 points, it would have been 1 minus a minus 5. 1 minus a minus 5 over 0 minus a minus 2, which would have become a plus 2 and a plus 5, which would have given me 6 over 2, which would still give me 3. Any 2 points I choose. They only have to be next to each other. Let's go with 4/13 and the negative 2/5. There, we have 13 minus a minus 5 over 4 minus a minus 2. That becomes 13 plus 5, which is 18, over 4 plus 2, which is 6, which again is going to give me a 3. Any 2 points in that table, choosing any 2 points in that table, working with the formula, I'm going to get that same slope of positive 3. So don't panic when you see a table. Choose 2 points, work with the formula. Here we've come to the you-do. 3 problems, give them a try, pause the video, we'll come back and I'll go over the answers. Welcome back. First problem is going to be 8 minus 5 over negative 2 minus 3, which is going to give me 3 over negative 5, which can't be simplified, so we have negative 3/5 as our slope. Over here, I choose 2 points. I'm going to work with the first 2, so we're going to do 2 minus a minus 1 over negative 1 minus 3. That becomes 2 plus 1, which is 3. 1 minus minus 3 is going to give me negative 4, so I have negative 3/4 for my slope. Over here, I can work with rise over run. Going from this point to this point, I actually have to go down 2, and I have to go over 4. So the rise would be a negative 2, and the run would be a positive 4. That can be reduced to negative 1/2. See you in class.